So this is exactly where we want to land, and from that picture you can see it's very self-similar one place to another. Our mission is not about driving from one polygon to another, it's about digging down through the layers of soil from the globally distributed dust storm soils that are at the top through the modified soils that water has worked on down to the ice layer. That's our mission, not driving. And let's see, I think I have one more slide that shows the comparison between Martian winter and Antarctic summer on the Earth. And it has very similar shapes. You notice those kind of polygonal shapes on the right. You see the same on Mars. So there are a lot of similarities between the Antarctic, which is still wetter than Mars is, and the Martian winter in the Arctic regions. And finally, we have a sophisticated weather station. And working in coordination with the three orbiters, we study polar weather from both above and below the atmosphere. And we have actually been able to make a prediction for the weather on our landing day, Sunday. And if I can have the next graphic, it shows the arrows pointing to our landing ellipse, which looks small in this projection. And this is data taken by the MARCI instrument on Mars Reconnaissance Orbiter, that instrument is led by Mike Malin, who is a member of our team. And we are having daily images to show the weather. The weather is good for our landing on Sunday, no dust. Our goals are understood now. The instruments are in top shape. They're all calibrated. The team is trained. The University of Arizona's Operations Center is ready to support the mission. And we are ready to explore the northern plains of Mars. And to tell us more about how we're going to get there on Sunday is Barry Goldstein, our project manager.
Thank you, Peter. I was going to start off by talking about the journey, the 10-month journey we've taken to get to Mars, but before I go there, Peter, Ed, and I were reminiscing before we started this briefing that this journey actually started about 5 years ago when we submitted our proposal to achieve what we're doing. It's kind of surreal now that we're only about less than 4 days from landing. Can I roll the first video, please? We launched Phoenix on August 4th, 2007, and as you can see from the video of our trajectory, we don't take a direct route to Mars. As of today, we've traveled 419 million of a total 422 million miles anticipated exactly for our journey. As of now, we are 167 million miles away from Earth, and when we get to Mars on Sunday, we'll be 170 million miles away from Earth. At that distance, it takes light and the radio signals 15 minutes to reach Earth. So the 15 minutes between our cruise stage separation and landing is almost the exact time it's going to take us to find out how things happen. One of the things that we do during the cruise is we actually pinpoint our landing site. And so over the course of the past 10 months, we've actually planned 6 maneuvers, 6 changes to our trajectory to pinpoint the landing site that Peter showed you here on the globe. It turns out that the vehicle is behaving so well, and the spacecraft team in Denver, as well as the navigation team at JPL, have been doing such a great job characterizing the spacecraft that we actually skipped one of our maneuvers. Can I roll the next video, please? What you see here is an animation of our last 2 maneuvers that we've done. The vehicle actually is traveling on a direct trajectory at this point towards Mars, but we turn, not as quickly as it shows in the video, but we turn to our attitude where we burn our thrusters. We turn on our trajectory correction thrusters, and we make our adjustment, and then we turn back. We do a full turn. This is an example of what we actually accomplished this past Saturday night when we did our what we call TCM5, Trajectory Correction Maneuver number 5. The next video here, if I can start rolling that, we'll start to show where it is we're going. Peter basically zoomed us into our landing site, and as you can see up in the Arctic region, the landing ellipse that Peter talked about. As of now, the green ellipse should show up here any moment. That ellipse is approximately 80 kilometers in the long axis and about 20 kilometers in the wide axis. And what we've done over the course of the past 8 to 10 months is we've actually used the HiRISE instrument, which is the high-resolution imager on the Mars Reconnaissance Orbiter, to literally map out all of the rocks in our landing site. And pretty soon here this image will fade, and you will see an overlay of color codes. And what you'll see is that we've literally counted all the rocks in green, if this ever gets there. Oh, what you're seeing now is the different probability ellipses of where we will land. This is the 80 kilometer, what we call 3 sigma, 99% ellipse. The target just showed up. That was our certified landing site target. The center of the ellipse right on the screen now is where our latest solution shows we are going to go. What says there as OD56 is actually where we were before TCM-5, our maneuver this past Saturday evening. The color can you go back to that last still, please? Thank you. The color coding you see on this map here is actually a result of all the auto counting and manual counting of rocks that we've done from the high-res image that I spoke about. And everywhere that's green is an indication within what we call 1 hectare, which is 100 meters square. There's at most 3, at least 0, rocks of 1.5 meters and above. And we use this to basically assess our safety from a touchdown safety point of view. Much of what we do in EDL is looking at our probability and our margins, and one of the biggest risks for Phoenix was the rocks at the landing site, and so we used high-rise to help mitigate that risk to the best extent. So where we are at this point is we are looking very good toward the target. We're working towards this coming Saturday and making a decision probably on Friday night whether we're going to execute our last trajectory correction maneuver, which will occur if we do it at 8 p.m. Pacific on Saturday evening. But as of now, it's looking very good, and we may not need to do that maneuver, and we shall see. We will continue to work that contingency. Well, what happens when we get there? Can we roll the EDL video, please? Before we get to Mars, we are traveling at about, relative to the surface of Mars, about 6,100 miles per hour. We accelerate to about 12,600 miles an hour when we separate the cruise stage 14 minutes before touchdown. At about 7 minutes after cruise stage separation, we enter the Mars atmosphere. At this point, we are now heating the heat shield up to 2,600 degrees